All right, so ladies and gentlemen, let's begin our command. Can you please confirm if you can see my screen? Please confirm quickly for me. I need to be on the pace with you because we have a lot to do. Can you see my R Studio?
Yes, Doc, we can see.
So when you open the R Studio, it's usually like this. When you click on this arrow here, it opens. This section here on the left is one space. It is called the command window. Okay. It's known as the command window. So this is where you type commands. And then this other place is called console. Console, that's where the results will show. Then on the top right here, when you click this arrow, okay, when you click that letter arrow, you will notice that you'll be able to split the whole thing into 4 parts. So you have the command window on the top left, the console, the top right is the data, and then you have the packages and plot on this section here. All right. So what we are going to do now is to go to the commands where we normally type the commands, and then we'll do the command typing. In your document, in your PDF document, I've written all the commands for this Brukutu dataset. Every command I've written. The first and the most important command is to load the data from Excel to R. When you look here on the sheet at the bottom, the one we worked with last week was this. Okay, we have the Brukutu, which is the left one here, and then we have the Brukutu R. Okay. The one we are going to use today is a Brukutu R. That sheet is what we are going to use. Now, in your assignment I'll give you, I will also give you Brukutu. Sorry, I will also give you a data set that has categorical variables like location, occupation, and religion. And you can see that they have English names. These variables have got English names. So I will give you something similar. Of course, it's not going to be Brukutu. And then I will ask you a series of questions to do, activities to do, just like what we're about to do. And then answer some questions related to it. That is for the assignment. But for exams, I will do everything, give you the results, and ask you 13 questions about the results. But for the assignment, I'll give you the data, ask you 22 questions, and then you put yourself in groups of what you already have. And then you will work in those groups and submit that assignment in 10 days. So please take note of that. If you have a question on that, please let me know. All right, so this is a data set. Okay, the first thing we do is that we go to the R Studio, and then we type this command. In this very example, if you have yours, you can just copy and paste like I'm doing. Copy the data set like this. You toggle to your R Studio here. It's empty. Then you type what? Gen equal to read.delim clipboard. This command, I named it Gen because the name of the data set had to do with Brukutu Gen data. But when you have your own data, let's assume that your data is oil and gas. You can just give it a name called oil, or even O. It can be a letter. It can be a word. So this is the data. That's the name we are calling it in R. Okay. And I want to now bring the data set in Excel. This is a data set in Excel. I'm going to just highlight the entire data set by clicking Control A. I'll do Control C to copy the data. I'll come to the R. I will not paste. I'll not paste. I'll not paste. I'll just click anywhere in the R. Then I'll just run it. Where did I click to do the running? The running is at the top here. You just click Run, and then the data will show down here in the console in blue. The data will show down in the console in blue, which means that the data has been loaded into R. How do we confirm the data has been loaded into R? Well, you can go and type the name of the data set, which is Gen again. So I just type GIN, run it again. You see, when you even type GIN, the whole data set in Excel sort of is shown here. But when you look at the bottom here, okay, you see that the data is also showing down there in the bottom. Anytime you type a command and you run it, okay, I just ran the GIN as well. The cursor will go to the next number. The cursor will go to the next number. So far, so good. Some of you should follow me in the process. So now we've loaded the data. There are a few things you can do with this data. Okay, when you go to your document, you can see we can generate the descriptive statistics. Okay. I want to just generate the descriptive statistics. So I copy the data and paste it here. Now remember, when you are doing your own with the data set, your data set I'll give you, you can't come and copy this. You have to think of the name you give to it. I called mine Jane. You can call yours Kofi. You should use whatever name you're comfortable with as far as the data is concerned. It must not be a word. It can be a letter. So this command says, I want you to give me the summary of the data. So let's click run. It's able to give me a summary of each variable. Okay. Each variable, I got a summary. So for example, kill, P, C, M, lock, get a summary of everything. Okay. Now, we've done this summary already in Excel. Okay. You can now install packages. Anytime you see something I require, and by the way, I'm copying and pasting. Anytime you see something I require something in a bracket, it means that something is a package. If you don't see require, but you rather see library, okay, something in the bracket, okay, and I'm typing some library information. You will notice that anytime you type require something or library something, that something is a package, which means you have to install it for the first time. So you click to install it, you click on the packages here and choose install. When you click on the packages and choose install, what you're going to do is that the pop-up will come like that. Then you will type the name of the package that you have. In this example, it is psych. So you type PSY, and you see that the data, the information will show by itself. You click that, and then you click install. This is one time, first time. Now, in my case, I'm not going to install because I've already installed. But I have the next one, which is the library Harold miscellaneous. The same thing, but I'm not going to install this one too because I have already installed. Once you have installed these two packages, there are a few other things you can do with your web. The next one is you can describe the data set better by using this command called describe. So we've done this in, like I said, in Excel, but we are doing it first time in R. So once you type describe into bracket the name of the data set, it will give you a summary statistics of everything. Please remember to run this one by clicking on the run, the psych, as well as the H miscellaneous before you start. Then you can run the describe. I just did. I just did. So you can see that it gives a bit of description of every variable. Okay. Every variable that you can have. It gives even some missing values. It gives a minimum and the maximum and some other things. A bit of information for every variable. It gives you those information. Okay, so you can see this thing again in the story. Now, there are a few things you got to know. There are a few things you got to check. One of them is check whether the dependent variable, in this case, the quantity demanded of gem bitters, check whether it is normally distributed. By the way, guys, what do we mean when we say something is normally distributed? In this case, the quantity demanded of gene bitters is said to be normally distributed. What do we mean? We've done this word normally distributed many times. So I want you to bring your knowledge to bear. What do we mean when we say that a variable is normally distributed? Okay. So the bell-shaped curve is a significant way of describing the normal distribution curve. It means a majority of the data point is in the center. To test for normality, what you do is that you can use this command here. I've typed it, but your own has to change by determining which one is the dependent and which one you are dealing with. So I want to use, there are 3 ways to determine normality graphically. The first one is known as quantile normal probability plot. This is in your slide. I just ran that. And on the right, you see the results there. Okay. This is the result. The result shows clearly that the blue, which are the scatter plot, are not beautifully seated on the red line. They are not beautifully seated on the red line. Therefore, the data is not normal. In other words, the quantity demanded of gene bitters is not normally distributed. That is one way to show the normal distribution graph. Another way of showing normal distribution is by using what is known as the histogram. The histogram. So I can use this command and run the histogram. Remember that in this one that I'm typing, the bracket didn't close. So I need to go and close the bracket. And now you can run the histogram. Look on the right. Look on the right. That's where the results is going to be under the plot. And again, you can see that the histogram is showing that there are 2 modes. Okay? This data clearly shows that the quantity demanded of gene bitters is not normally distributed. How do we know? Because a histogram should have some smooth curve. Okay? And for normality, it has to have a smooth curve. But this one that you guys are seeing, it doesn't have that at all. It goes here like this, gets here, goes down, and then gets up again, like that. So it's not normally distributed at all. Therefore, the histogram is also giving us a clear indication that the data for the variable Q is not normally distributed at all. Let's look at another final plot you can use. It's called the density plot. So I just copied and pasted that here in number 10 here. Plot density into bracket gene $Q. Let's run that and look on the right. Okay. Oh, by the way, this one you can add color. So you can just go and copy this one here, this one, and then come and put the word here as common color blue. You can put it there, common color blue. In fact, the line weight, you can even change it. You can even change the line weights, which I just did. Let's run the whole thing again and see. Okay, so there's some kind of typo. Whenever you get typo like this, just take your time, go through it. Okay. So I need to remove this. Now it should look better. You can it, and then here you go on the right. You can see that it is showing blue. It's showing blue. And also it's showing that the mode is 2. So this is bimodality. Okay. The mode is actually the peak of the data. See, you got to write everything I say, because it will not make sense now until then. The mode is the peak of the data. You see, if you have a normal distribution, it has only one mode. Actual normal distribution goes like this. Okay. Goes like this and then comes that way. Just one mode. But because this one is clearly, graphically not normally distributed, you can see that it is multimodal. So all of these graphs, you draw all of them in your assignment to show how normal distribution is for a particular variable. You can also show a scatter plot of the data for just price and quantity. This graph will help you to do that. A scatter plot of just price and quantity. I just want to do that here. Then you can look on the right to see the picture of the result. This is a scatter plot. I want it to be red between price and quantity demanded. I want it to be red. I highlight it, I run it, and there you go. If you look at the scatter plot on the right here, does it show a positive or a negative relationship?
A negative relationship.
Very good. It shows a negative relationship. Very soon, we'll apply some line to it. Now you can see clearly that it shows a negative relationship. Now, this plot is cool. It's fine. It's cool. You know, we can even generate a scatter plot matrix. Okay, so this command, you can use it to generate a scatter plot matrix of some of the variables or all of the variables. Let's try that. Now, scatter plot matrix means that you have just more than what you have here. You see, the one I just have here is for just quantity and price. But what I want the software to do for me is to give me all of it. One that is everything, not just quantity and price, but for everything. This is a command use. It tells you clearly that some of the variables are not numbers. You know, in other words, they are categorical variables. Okay. So you have to double check, make sure that everything is in order of the data set. Okay. Now, if some of them are not numeric, what you want to do is to just omit some of them. Let me just omit some of them and just take QPCM. These are numbers, they are not dummy. Remember, the dummy variables are the LOC, OCC, REL. That's the location, occupation, and then religion. I've removed them. So let's run the 10 again and see. Well, it's still showing clearly that there's a problem somewhere. Okay. It still shows that there is a problem. And it's all right. So when you normally face problem, sometimes the only way, I think there's a comma somewhere where it shouldn't come. Okay. I can't even see anything that is a problem. Okay. There you go. So look on the right. Okay. That's the data now. So on the right, you can see clearly a scatter plot matrix. And you can look at each one of them. If you look at this first one, price and quantity demanded, looks negative. What do you see about quantity and complement? This one, quantity and complement. What's the relationship there?
It's negative.
Quantity and complement. Is it positive or negative?
Positive.
Positive.
It looks more positive. So you can do this scatter plot matrix and find some more information. Okay, some more information in there. All right. Now, you have to find another way to actually find that of the rest, whichever one. Find a way to actually address these things. All right. Now, you can generate the entire correlation itself. So you can generate a correlation matrix. Remember that we generated a correlation matrix in Excel, but those times the variables were coded. But here they are not coded. So if you want to get a correlation matrix, you can remove the coded, the categorical variables. And this command does that. So I can go here, remove the categorical variables. I need to now copy this. Remove the categorical variables, as you can see there. Okay. And then the removal button is when you do minus which names, and then you list the names. You can see that here I've listed the location, the occupation, and the religion. LOC, OCC, area. So let's run that. You see the correlation matrix will appear. Okay, let's run that. Click on this run, and then the results are showing down here. You can see the results of the correlation down here within the parameters of that. Who has done this, and is there any question? So who has been able to generate, like I said, I'm moving faster, but then there's always possibility of someone being able to do this. If you're able to do it, you follow me, you tell me. So this correlation, I will not ask questions because we've done it already in Excel. But you can do the correlation with, because this one has got so many decimals, so you can remove the decimals. Okay. You can remove the decimals. So let's do another correlation, this time round it to 2 decimal places. And I'm going to do this. This is a correlation I want to do with 2 decimal places. So I'm going to go to the R. And I'm going to run the correlation with 2 decimal places in mind. Now watch carefully here. I wrote locate, but it's supposed to be LOC. I wrote OCCU, but it's supposed to be OCC. So let's now put that into the R and then run it to see the correlation with 2 decimals. You can see that the top one here had a lot of decimals, but then the down one here has just 2 decimals each. And you can see that the 2 decimals is the one shown here. The number shown here, that is what is showing the 2 decimals. So you can do correlation with 2 decimals. In fact, some of your data I'll give you as an assignment. I'll ask you to generate correlation with 2 decimals. That's why I'm showing you this. All right. The next thing is to generate correlation with p-values. Okay. So once again, I'm going to remove the variables that are categorical. When I say categorical, I also mean dummy. Okay. I also mean dummy variables. So let me check this and then go to the R, type your variable names, remove the ones that are not supposed to be there. Now let's run this result. Remember, we are generating correlation with p-values. So for example, you can say that there's a strong correlation between A and B. But then even though it's strong, is it significantly strong? That is what the p-values do. Let's run this correlation with p-values and look at the bottom here. The results are just amazing. At the top here, you're able to see the correlation between each variable and another variable. At the bottom, you have the p-values. You have the p-values for each one. So as an example, who can look at this and tell me the correlation coefficient between P and what? P and M. What is the coefficient? Because the ones here at the top show the coefficient. P and M. What is the value? That is the price and income. What is the correlation coefficient there?
0.51.
What is the correlation coefficient there?
0.51.
Negative 0.51.
So you get this value, which is negative 0.51. Never ignore the negative when you are mentioning it. So this is the negative 0.51. Now, if you want to check whether it is significant, you have to come down. Okay, this is P all the way up to M. Okay, so if you want to know the P value, that is this value. And when you look at that value, it is equal to what? 7 with the exponent of e to the power 4. What does that mean? What it means is that there are 4 zeros before the 7. That's what it means. So you have 0, that's 1, 2, 3, 4, 7. That's what it means. It means that there are 4 zeros before the 7. Good. And when you look at it carefully, that shows that it's significant. Because whenever the p-value is less than 5%, it means that the correlation is significant. You got to write it down, you forget. Okay. Whenever the p-value is less than 5%, the correlation is significant. All right. So we've been able to generate correlation, and we've even done one with the p-values. Now we are ready to do a scatter plot of the simple regression. Simple regression, you can use this to draw the regression line. Remember, as the name sounds, it's a simple regression. So you go to your command, okay, type that, and then rename it well. And you can run this result. Look at the bottom right. That's where the results will be. I'm running this, and on the bottom right, you can beautifully see that we've been able to show the true relationship between the price and quantity demanded. It's clearly showing a negative relationship, and the line is helping us to see the bigger picture. You will be asked to do a similar thing for your data. Okay. Now, let's do the normal regression, the simple one. The simple regression is Gen simple. That's how I call it, Gen simple. Okay. It's just between price and quantity demanded. And just look at the results. Okay. I'm running this simple regression, and the results is down here. It looks very simple. And clearly, you can see that price is the only variable that is here. The fact that price is negative 14. Look at the estimate for price. This is the estimate for price. It's negative 14.26. And this confirms that there's a negative relationship between price and quantity. We will look at the rest and put it all together. Let's run a multiple regression. What we just did was a simple regression. So let's now run a multiple regression and see the relationship between quantity demanded and all of the other independent variables. You can use this very command here to run a multiple regression. I'm going to do that. Now remember, these commands, I've written them. So I've written them myself. So sometimes when you are doing yours, you got to recognize that you are going to do the write-up yourself. See, the other ones that I'm showing you here, I wrote them myself. In your assignment, you got to write them yourself. So I just do the G multi. Watch carefully. I wrote a Q, the dependent variable P plus C plus M plus LOC plus OCC plus REF. All of these are independent variables. I ran it, boom. The results show in the console down here. And this is the result. I'm going to ask you questions. In the assignment, you will run it all by yourself, and then you will still answer the questions. In your exams, you will not run anything. I will just show you the results like this that I'm showing you, and then I will ask you about 13 questions. So are you ready for the questions? Please take your pen and paper and be writing the questions down. Most of the questions, all of them are actually in your slides, but I want you to write them for a good reason. I want you to write the questions for a good reason. It will help you later than if you are just listening. Question number 1. It says that specify Burukutu Ventures regression model. Specify Burukutu Ventures regression model. Who can tell me how to do that? specified Book-to-Ventures regression model. Who can tell me how to go around that?
So,
Yeah. Yeah, who has an idea? Okay, so to specify the regression model, this is important. If it is under exam condition, it's actually 8 months. So it's very important that everybody knows how to do that. So I'm going to do that together with you. Regression model, you start with the dependent variable. And in this, our analysis here, the dependent variable is Q. So you write Q. Then you bring equal to. Then you write your beta naught plus your beta 1. Then you go and look for your first independent variable. Who can tell me what that is? What is the first independent variable? Christian. No. There are 3 religions. You have Christian, you have Muslim, and then there's
Buddhist.
Buddhist.
So that is a Buddhist. Buddhist is the reference category. So the one that is not usually brought here is the one that is the reference category. For occupation, which is a reference category?
Was fishing.
Very good. And for location, what is a reference category? Location is rural. All right. So this is how you write the specified regression model. Take note. You change anything, okay, but you've not finished. The last thing to bring is the error time. It's easy to forget that, and yet without the error time, everything is zero. Without the error time, everything is zero. Take note. Take note before you see it somewhere and say that I'm sorry. All right. This is a specified model. It's different from the estimated equation. If you never watched my videos after we've met in class, please go back and watch them. Because sometimes I see lack of a person following the next one is because of their inability to watch the first one. Now, the next question. Write the next question down. And that is, write the estimated regression equation. Write the estimated regression equation. Who can tell us how to write the estimated regression equation? In order to write the estimated regression equation, you are going to use the column of the estimate, which is the same as the coefficient. I'm going to write them down in that regard. So it's the same thing that we wrote as before. The only thing is that we are going to replace the beta parameters with the numerical coefficient. Always convert the coefficients into 2 decimal places before you show it. Convert the coefficients into 2 decimal. Okay, so who can tell me what to be on the left-hand side?
Q.
Q. So you have Q, okay, which is equal to, the intercept is what? 280.27. Okay. Then you bring minus because the next value is price coefficient, which is negative 3.15. So that'll be 3.1, and I'm talking about this. 3.15, then you attach the P. Then minus, what's the next one?
0.10.
It's 1. Remember, you are taking 2 decimal places. Okay. If you make some of those little mistakes, it will be penalized. Then you have income. Income is negative 0.98 M. You have net location urban, which is negative 5.11. That one you write it in full, log Ehrman.
Okay.
Then the next one is minus 19.43.
Oh.
You have to correct it to 2 decimal places, and that is teaching.
Teaching.
Then the next one is negative 46.47. That is occupation trading. And then you have plus, because the religion Christian is plus. So you get 15.55. And that is religion Christians. And then the last one is negative 23.01. And that is religion Muslim. Don't add the error term here, because the estimated equation does not have the error term. So this is how you write the estimated regression equation. This is how you write the estimated regression equation. And any question? Now let's go to the next. The next question is, which independent variables are statistically significant? Which independent variables are statistically significant? What does this mean? Who can tell us? What this means is that you are to tell whether a particular independent variable significantly affects the dependent variable. Whether it has a strong explanatory power. In order to do that, for an independent variable to be significant, its p-value must be less than or equal to 5%. The p-value must be less than or equal to 5%. So forget about the intercept, it's not part. If you look at the p-value, where do you get a p-value? The p-value is a section that has probability, PR. That's where the p-value is in the data set, in the results. So based on that, who can tell us whether price is significant or not? Is price significant?
It is not.
Always convert everything to 2 decimal places before you talk.
Okay, it is. It is.
So price is significant because when you convert it to 2 decimal places, that is also 5% exactly. Okay. Now we go to the next variable, which is complement price. C. Is it significant or insignificant?
It's significant.
What's the p-value?
It's 0.1.
0.01.
0.01. Very good. Income. What is the p-value?
0.20.
Okay. Is it significant or insignificant?
Not
It's significant.
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 Okay, good. Because the value, the p-value is 20%, which is way big. Log urban, occupation, log urban, is it significant or insignificant?
Not significant.
What's the p-value?
0.1.
0.19.
Exactly. So, ladies and gentlemen, when you look at the next one, which is occupation teaching, significant or insignificant?
Significant.
Less
Very
than.
good. What's the value?
0.00.
Okay, always use, when it is 0 there, you forget it. You just say 0.
Yes.
Occupation trading, significant or insignificant?
Insignificant.
Insignificant, not significant.
Huh? If you don't know the
Insignificant.
value, if you don't know how to write this value,
1.8.
1.08.
it's not 1.08. Remember, it is
1.0.
0.00001. Yeah, because it's 6 zeros.
9.
not 6, it's 9.
It's 9. Okay.
Significant.
Okay, so the value is simply 0. There are 9 zeros before the 108. The value is simply 0, and therefore is significant. Religion Christian, the values are 5 zeros before the 116, so it's significant. Religion Muslim is also significant because the answer is approximately 0.
Yes.
Doc, I think I noticed something. There are some asterisks, 3 asterisks on the side, and it's like they're all significant, like they are 0, 0. What do those asterisks mean?
So that's my next thing I was going to talk to you about. You notice that variables that are significant also have a star, but the star differ. So here are the conditions. And please take note, because that comes also in another question that you'll be asked. And here is the thing. When you are doing this thing, 3 star, okay, 3 star means it's significant at 0.1%. Take note. Two star means that it's significant at 1%. A star means that it's significant at 5%. A dot means that it's significant at 10%. That is how far we always go. So sometimes you can be told that the thing, is it significant or insignificant? By significant, then you are told that significant at what percent? So when you look at something like C, C is already significant, but significant at 1%, what percent? Who can tell us? C is significant at what percent?
1%.
1%.
1%.
That's it. So you should know all of these significant elements. Let's move on. So we'll be able to tell which variables are significant. Now let's check whether all of them put together are jointly significant. All of them put together. Yes, Avia.
Sorry, please, you said that if it is a dot, it is significant at I think you said 10%, but then is that 10%? But then the P, which is 0.05, is 5%, but it didn't have one star. It rather had
Because
a dot.
at this point, we were using only 2 decimals. But when you take all of the decimals, which is what the software is using, you will see that this value is not 5%, it's 5.3%. If you check carefully, it's 5.3106%. But we rounded it. So if you are being told that what is a percentage, what is a significant level, okay, and correct to 2 decimal place, you got to keep it at 2 decimal place. But if you are asked that it is significant at what percent, you have to ignore the rounding and then use the actual values that is there. And that actual value will always correspond to the dot or the star. Does that answer your question?
Yes, I guess.
Okay. That's it. That's how it's supposed to be. Okay. Let's go to the next question. Are the coefficients jointly significant? Write it down. Loretta.
Good evening, sir. Good evening, Doc. Please, I want to take us back a bit. The org trading and the real Christians, even though the p-values are 1.0 something something, you said they are significant because of the E-09 and the E-05. I would want you to retrace that because I'm lost with regards to why it is 1% and it's still significant.
Are you talking about the last but one and last but two?
Yes, sir.
All right. So this is a very powerful term in numbers. Anytime you have a number, and then you have, let's say, 1/4 e raised to the power negative 0.5. What it means is that it simply means that there are 5 zeros before the 1/4. So you write 1, 2, 3, 4, 5 zeros, then add the 1/4. Then you can go and put a dot after the first zero. Okay. It means that there are 5 zeros before the actual number. That's what it means.
Okay. Okay. Sir.
Anytime you have something like 4, 8, e raised to the power 0.
The prices and the cost on the what has really deal when it come for
I don't know who the person was, but that person simply is not following, is not listening. And such people like this, I can see the end. You know, they are not paying attention, and we are just able to hear it because they didn't also mute themselves. So you can imagine if that is what a person is doing throughout, and is on the class, why wouldn't that person struggle? Why wouldn't the person struggle? Because this one, when you're even close to it and you're paying attention, it's not simple. And now the person is just doing something else. Okay, let's move on. You see, you don't make life easy for yourself, but you should make life easy for yourself. When you recognize that something is not going the way you want, you rather want to put everything away and concentrate your attention more than ever. Okay, so the question was, are the coefficients jointly significant? That talks about the combination of all the independent variables, whether together they are influential. Now, the way you answer that is always to use the p-value of the F statistic, which is always at the very bottom. Take note. Use the p-value of the F statistic to determine the joint significance. If you are taking notes, you're going to be writing all of this. So if you look at the p-value there, based on the question asked and my explanations a few minutes ago, if you look at the p-value, what is the value of the p-value?
2.2 e.
So that is equal to what value?
0.000.
So that is equal to what value?
0.
See, they didn't understand the question. So that's why they keep going.
2%.
All right.
Doc,
So let's
please
move on to the
repeat
next.
that
So
again.
now that it is 0, it means that the independent variables are jointly significant. So on the basis of that, you can say that the independent variables are jointly significant. That's it. So that is the answer to your question. Let's go to the next question.
Doc, hello, Doc.
Yeah.
Please, I didn't get that portion. Can you kindly take it again?
Which part? Which part didn't you get?
The F statistics, the p-value.
The p-value of the F statistic is this, which is 2.2. Okay. e raised to the power negative 16. And that simply means that there are 16 zeros before the 2. I explained that before, which means that it's absolutely zero. If there are 16 zeros before a number, it means that the number, everything is zero. So in simple terms, this p-value could have easily been written as p is less than 0. That's it.
Okay. Thank you very much.
If it is 0, it means that it's less than 5%. And we tend to say that something is significant if the p-value is less than 5%. That is how this one is. So you are able to tell the joint significance always by looking at the p-value of the F test. Next one. Write it down, please. Is the regression model reliable? Is a regression model reliable? I'll also use the word suitable. I will also use the word, and you have to take note of that too, well fit. Is a regression model well fit? The fitness of the regression model is determined by certain things. And please check your notes as well. The fitness of the regression model is determined by certain things. One of them, or most of them, is given by the multiple R square. Take note. The multiple R square measures the variability in the dependent variable as explained by all the independent variables. It measures the variability in the dependent variable as is explained by all the independent variables. As is explained by all the independent variables. Now, when is the regression model well fit? And take note, if the R square is greater or equal to 50%, according to her, a black. If the R square is greater than or equal to 50%, then we say that the regression model is reliable, suitable, dependable, and well fit. All right, so based on this, who can tell us our regression model, is it well fit or is not well fit, and why? Who can tell us?
The place is well fit.
Right.
Well fit. Because 0.98.
9.
Please convert it
9.
to decimal place when you're talking.
Where's the R?
0.9 is 0.99, which is
99%.
greater than 50%.
Good. Now, before we come to interpreting that value, 99% now, before we interpret it, there's another R square called adjusted R square. What is that? Take note. The adjusted R squares penalizes the inclusion of irrelevant variables in the regression model. Write it down. The adjusted R square penalizes the inclusion of irrelevant variables in the regression. So let's get something right. In this very data, we had price, complement price, income, location, occupation, religion. We had all of these. The regression model, these independent variables are said to be relevant. That's why they are there. Suppose we had included something like, rainfall. There is really no connection between rainfall and the quantity demanded of gym betters. But we include that, and this is irrelevant. But suppose we had included this irrelevant point. What it will mean is that because it's not relevant, the R square is supposed to go down. But the R square doesn't go down. That's why the adjuster is there. The adjuster comes to reduce the R square value a bit. And so every time the R square will always be greater than or equal to the adjusted R square. Take note. The R square will always be greater than or equal to the adjusted R square. When do you think they will be equal? Who can tell us? When do you think the R square and the adjusted R square will be equal?
And no irrelevant variable.
Excellent, perfect answer. See, these are the sort of questions you tend to get to prove that. So in our own, you can see that correct to 2 decimal places, the adjusted and then the R square, both of them are 99% on average. And that indicates that there are no irrelevant variables in the model. There are no irrelevant variables in the model. So take notes and have a full understanding of all of these. Next question. You're learning now. You're really learning. So how will you interpret the R squared, which is also called the coefficient of determination? Now we know that our R square is 99%. How do you interpret it? Who can interpret it? This means that 99% of the variation in the dependent variable, 99% of the variation in the quantity demanded of gene betas has been explained by the entire regression model. Another way of saying this is that 99% of the variation in the quantity demanded of gene betas has been explained by all the independent variables. Has been explained by all the independent variables. So that is how you address a regression situation. That is how you address the regression situation. All right. So who can now, by the way, what did I explain is there. Next question. The next question we're going to do is to look at multicollinearity. Multicollinearity is something we've already seen, but we're going to ask a question based on this. Remember, multicollinearity is about independent variables. Don't forget. It's always about that. If you want to check the presence of multicollinearity, use something called variance inflation factor. The variance inflation factor tells how much the variance of a particular variable's coefficient, how much that is inflated because of the presence of multiple. Because of the presence of multiple. So let's go back to our independent variables that we have, if you can remember. We were able to identify some variables that were multicollinear. Do you remember? We use this very correlation matrix. And if you can remember, the first variable, we said that the dependent variable column is not part. The first coefficient that we identified driving multicollinearity. Do you remember that coefficient? Here. Is 0.76. 0.76 was the coefficient we found last time that indicated that price and OTR were multicollinear. Then we selected two other ones. Do you remember? Okay. We had negative 0.74. And then finally, we had negative 0.73. So these three variables were the top three multicollinear pairs. So what is driving this multicollinearity? If you take the first one, okay, it is price and then OTR. So we have to check between price and OTR. One of them is bringing about a multicollinearity. We have to check that. The next one is price and complement. Okay, one of them is driving it. The next one was M and M and RM. And you can see that they also. So what we are going to do is this, take note. We are going to look at the variance inflation factor for each one of these variables. The one with the highest variance inflation factor must go. The one with the higher variance inflation factor must go. So when you look at this one, before we do that, please take note that dummy variables, we don't even look at their variance inflation factor. So all the dummy variables, we will not want to consider their variance inflation factor. Why? Because dummy variables are static. They are not changing. So when you tell me that this guy and this guy are multicollinear, that is, they are moving together, then it's like one of them, they should have to be moving variables. But then dummy variables are not moving variables, and that is why you can't consider them. So we are going to calculate the variance inflation factor for all of these variables. In fact, the software does that automatically for you. So let's go back to our R here. Inside this R software, we can now run something here. Let me show you. You can run something called library J2s. Library J2s. And after running this library J2s, let's run the gene multi result again. So I just did that. And it gives a very nice result, this time with p-value. But we are interested in the VIF. So we run this sample according to Fox and Monet. And now it gives us the VIF, the variance inflation factor, for each one of these variables at the far column. At the far column there. We are able to get a VIF. Now, remember that we've already said that the VIF for those that are dummy, we don't need them. So location urban is a dummy. So we will not need that. Occupation teaching is a dummy. We don't need that. Trading is a dummy. We don't need that. Religion is a dummy. We don't need that. Muslim is a dummy. So now we are going to focus on those variables that are not dummies, which is price, complement price, and income. So when you go to the variables that were identified to be multicollinear, you will notice that all the dummy variables will not be part. So the first one, which was P and OTR, the OTR cannot be part. So it means that a problem is being caused generally by what? By P. That's what it means. The next one. Now, please note that the question is this. Let me now go back to the question so that you can appreciate this even further. The question is this. Using only the VIF, and you might want to write it down. Using only the VIF, which one of the pairs of variables selected to be multicollinear may be deleted? Which one of the variables selected to be multicollinear may be deleted? Do you have an idea? Well, the first one that may be deleted is P. Okay. The second variable was P and C. P and C. So when you go to the variance inflation factor, check P and C. Which one is a problem causer? Which now one has a higher inflated value? It's P. If you look at the last column here, P has got a higher inflated value, and therefore that is the one with the issue.
That's C, oh. P,
But when you
okay.
look at C, the VIF is just 10.38.
Okay.
And we said that the one with a higher VIF must go. All right. Now, the third one is M and RM. Since RM, religion Muslim, is not really considered as part of the dummy variable situation, then R, what's the name? M becomes the major one to deal with. So M must go. Now, the word must go doesn't mean they should actually leave, but if there's a need to ever correct something, they are the ones to be corrected. All right. So multicollinearity is a bit of a problem for people, but it's always great. Now we are left with interpretation of the result. So please write this down. Just write interpretation. And the first one I want us to do is to interpret the coefficient of income. No, I don't want income. I want to use price. Please write this down, because what I'm about to give to you is important. This is 6 marks, and you do two interpretations. Interpret the coefficient of price of J. Please write that. Interpret the coefficient of price per J. Interpret the coefficient of price and J. Anytime you're doing the interpretation, you start with a message on average, on average, on average, on average. So let's start. On average, given the complement price of J. On average, given the complement price of J, given the complement price of J, the income of the people, the location of the shop, the occupation and religion of the people, the occupation and religion of the people, a 1 unit increase in the price of gin, a 1 unit increase in the price of gin decreases the quantity demanded of gin. And I'm just using the interpretation here to do it. A 1 unit increase in the price of gin decreases the quantity demanded of gin by 3.15 units. By 3.15 units. Okay. Who understands or who does not understand? Who understands and who does not? Okay, so when you look at it, it said a 1 unit increase in the price of gin leads to 3.4, a decrease. Why is there a decrease? Because the symbol here is negative. And because the symbol is negative, that's why there's a decrease. And also you can see that when I was holding the other factors constant, everything was given except the price which I was interpreting. So whenever you are interpreting any variable, that variable should not be part of those that are given. This point is a very important point. Very extremely important point. Okay. If you don't understand something, let me know. Now, how do you interpret that? Remember that price is changing. That is why we said that 1 unit increase. But what if price is not changing? Or what if the variable we are interested in is not changing? So I'm going to look at another variable, which is religion Muslim. Religion Muslim is a dummy variable. And as a dummy variable, it's static, at least within a year. So how do you interpret the coefficient? Because it's not changing, it's not rising and fall. This is how you interpret it. On average, then you mention all of the others except religion. That's how you do it. You now have to give all those factors given except religion. So on average, given the price and complement price of gin, on average, given the price and complement price of gin, the average income of the people, location of the shop, and the occupation of the people. Quantity demanded is expected or predicted to be 23.01 units less. Remember, I'm converting it to 2 decimal places. 23.01 units less. Quantity demanded is predicted to be that less if the people are Muslims than Buddhists. If the people are Muslims than Buddhists. Guys, if you are interpreting a dummy variable, you got to know what the reference category is. And because we are talking about religion, and in the sample space, the total number of religion was 3. So that is how you do the interpretation. Watch it. It didn't say that 1 unit increase in the price of religion. No, religion doesn't increase or fall. Rather, quantity demanded is predicted to be. It's predicted to be. In other words, quantity demanded is expected to be that or that. In this case, expected to be 23.01 units less is going to be less if the people are Muslims than if they are Buddhists. In other words, quantity demanded is expected to be 23.01 units more if the people are Buddhists than if they are Muslims in that regard. Who is not clear?
Please, you kept on referencing Buddhists, but I see Christians and Muslims.
Very good.
So I just want to find out if it
So
was
normally, when you are interpreting a dummy variable, anything that is a dummy variable, there is always a reference category. So note that anytime you are interpreting a dummy variable, you got to know the reference category. And this comes also in the story, in the preamble. You will know this long ago in the story. If you could remember, when we were beginning this story, we indicated that there are 3 kinds of religion. If you could remember, they were Christians, Muslim, Buddhists. Do you remember? You remember, or I should go
Yes,
to?
sir.
Good. So now that is at the back of my mind. anytime you're about to interpret any of the dummy variables, you've got to know the reference category. And usually the reference category is the one that is not in the result. So anytime I mention Christians, I'm talking about Christians relative to Buddhists. In this case, if I mention Muslims, I'm mentioning Muslims relative to Buddhists in this case.
Thank you, please. Thanks for the clarification.
What do you think the reference category will be for occupation? Since we have teaching and trading here, which one do you think is a reference category? That was not mentioned. That's not here.
Fishing.
Huh?
Fishing.
Fishing. Very good. Very good. And then for location urban, what do you think is a reference category?
That was rural.
Very good. You got to know that. So now we've been able to do interpretation. The last thing for today is going to be prediction. 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 Learn all the interpretation of the rest, okay? But for now, I'm just going to go to the last one for today, which is prediction. Prediction. Remember, one of the things we said about regression is our regression is used for two things. One, to establish causal relationship. In case you don't know, write it down. Regression is used to establish causal relationship. And two, regression is used for prediction. So here we have a situation. A situation where you can compare. Actually, first of all, you can predict the quantity demanded of any gene bitters, provided you know the elements. What are the elements? Okay. Suppose we know all of these elements. I've just used some acronyms again for this. Suppose we know the actual price of something, of the gene. Suppose we know the complement price, the income, the location being urban or rural, occupation being teaching, or, like suppose we know the location, we know the occupation, we know the religion, as well as we know the price, the complement price, and then all of the income. Then we can predict the quantity demanded of gene bitters, can't we? If we know every variable here, even mathematically, if we know all the letters, we can find the value of K on the left, can't we? Okay, so let's look at the first scenario. So this one is looking at two scenarios and then comparing them. The first scenario is that it wants us to find the quantity demanded of gene bitters that was made by some Muslim traders in an urban town. Compare that with another quantity demanded of gene bitters made by some Buddhist fishers in a rural area. But remember that in both cases, in both the Muslim and the Buddhist cases, remember that the cost of or the price of the gene bitters is 15. Remember that. Don't forget that. Also remember that the complement price is 15 and the income of the people is 20. So as long as you remember this, there is no problem. There is no problem. No problem at all. So let's look at the first situation. First, you need to rewrite the equation again. Do you remember the equation we wrote using the numbers? Now I'm using the equation here. This is the equation. Now let's take the first scenario. The first scenario says that price is 15. So whenever I see this P, what value will I put there?
15.
Whenever I see C, what value will I put there?
15.
Whenever I see M, what will I put there?
20.
20.
Very good. Very good. Now let's go to the question again. We are told that the people are Muslim traders in an urban. Muslim traders in an urban. So when you look at this equation, LU, which is location urban, will be what value? Now, note that
1.
it will be 1. And the reason why it will be 1 is because we are told that the people are in an urban area. So if in an urban area, then LU is 1. But if it was in a rural area, then LU would have been 0. So 1 means it's there. 0 means it's not there. It's a binary. It's a dummy. So LU will be 1. Now we are told that the people are Muslim traders. So OT, which is occupation teaching, will be what value?
0.
0. Occupation trading will be what? The people are Muslim traders in an urban town. Occupation trading will be what?
1.
1.
Religion Christian will be what? 0, because they are Muslims. Okay, and then religion Muslim will be 1, because they are Muslims. So take note of how you do this. So this is what I've done here. You substitute the 1, 0, 1, 0, 0, 1, then the numbers 15, 15, 15, 15, 15, 20. And then you now add them together. You'll get something like this. That's the first scenario. Let's look at the second scenario, the second situation. In the second situation, nothing changes. The only thing is that the people are now Buddhist fishers in the rural area. Buddhist fishers in the rural area. So how do you do that? Remember, price here will be what value?
15.
Complement price.
15.
Income.
20.
LU.
0. 0.
Good. OT.
1.
0.
How can it be 1? Okay,
Oh.
because people are Buddhist fishers. They are Buddhist fishers. So that's 0. Occupation trading.
0.
0.
Religion Christian.
0.
0.
Religion Muslim.
0.
0.
Some people are now getting it. So now I can hear the word errado. So you substitute these values. Okay, let's go here. That's it. You substitute these values and then you calculate. Those that are zeros will cancel. So in this case, most of the ones from here, they will all cancel. All of these ones. Okay, they will all cancel out. And then the final answer will be something like this. Now let's look at the second scenario. If you look at the second scenario, that's more than the first scenario. So you can see that the first scenario was 136 somewhere. The second is 211 somewhere. So you can see that the second is 74 more than the first. So the comparison shows that in the second situation, quantity demanded is rather more than the first situation. And what was causing the difference? Price was the same. Complement price was the same. Income was the same. So what was driving the difference? I know, and I know you know.
Occupation.
Religion.
And location.
Location.
So that's it. Those are the things that actually work in your favor. So that is how you undertake a regression up to the point of prediction. Go and run all the codes that I've given you, and this is going to help you big